All right, today we are talking about visualizing data. So, data visualization is the process of using charts, graphs, or images to visualize some complex data. We're making our data, all of our information, visual. We're making it so that we can see it and understand it in a visual way. As human beings, we are way better at interpreting and extracting meaning from information when we see it in a visual form rather than just looking at a whole bunch of numbers. If we can look at a picture, we're way better at understanding what's going on in that picture than if we just see a whole big sequence of numbers. So here is some data about the average weather conditions in San Jose. Across each of the months of the year, we have our average high, our average low, and our average precipitation in inches. And now these are all just a bunch of numbers. We can glean some information here. But if I do a graph with those pieces of information, we can see our average highs across the different months. We can see our average lows with those two lines. And we can see how much average precipitation we get in inches with that bar graph in the back. So we're combining multiple types of graphs here. And we can gain all kinds of information from this graph. We can see in the beginning and end of the year, it's pretty cold. And then as we reach the middle of the year in the summer, the highs get to pretty warm. Honestly, this isn't hugely shocking information, but it's cool to see how it looks on this graph. We can see rain is higher in January and February. It definitely takes a dive during July and August, and then rises back up as we get into the fall and winter. So we can, if we turn our data into a visual form, if we graph it, it becomes a little bit easier for us to parse. Now, data visualization is not only used in computer science. Since data comes from all kinds of different sources, there are all kinds of different fields that need to make use of data visualization to better understand their information. Fields like science, government, sports, agriculture, music, economics, medicine, disease, all these different fields and way more use data visualization to help people gain understanding of what's even going on. Now, people have been using pictures to understand data for a very long time. We don't need to use computers to visualize our data. I'm sure in elementary school you learned how to graph a whole bunch of points on a graph, and maybe it made a picture, or maybe you were just plotting points to see how this graph worked. Now, so we don't need to we don't need a computer to visualize our data. We can make graphs ourselves. And one very important type of data visualization might not come immediately to mind are maps. Maps have existed since at least the 17th century, and we're representing data about our globe. We're representing how large things are, what the shape of things are on paper or on a globe to make it easier for us to understand how our world is shaped. And even tools like the pie chart are older than you'd think. This was invented in the 19th century, which is a good deal older than computers are. So one of the oldest and most famous pieces of historical visualization was made by Charles Joseph Menard. And he made this very, very famous visualization of Napoleon's losses during the Russian campaign of 1812. So I'm not entirely sure how to interpret this because the letters are very small and also in French, so not super easy for us to read. But this is a super duper famous visualization because it's got a lot of information compacted into one thing. Now, he probably had some table of values of places, dates, all these kinds of things, and he had to carefully plot each point himself. He probably needed a good deal of artistic talent in addition to his desire to make this data visual. He needed some artistic talent to accomplish this feat of making this visualization. Now, fortunately, technology has come a long way since Charles Joseph Menard made his famous visualization. Computers have made incredibly large contributions to the field of data visualization. They let us process large amounts of data quickly. They let us update our visualizations to stay accurate if our data happens to change, and they can even give us interactivity in our visualizations. They also let us be very creative with how we choose to visualize our data, allowing us to blend science with art. There's entire communities on the internet dedicated to making data look nice. Like there's a subreddit called Data is Beautiful, where they present information in an eye-catching and eye-pleasing way. So you can feel free to browse that if you'd like. There are so many different kinds of data visualization that we can use. This is a very small screenshot from this website, GitHub, where we can see all of these different types of graphs or visualizations we can make. So this page is incredibly long. I'm not going to keep scrolling because there's so many, but there's lots and lots of different types of visualizations we can do. We're going to talk about some very basic ones here. First example are just tables. Tables are really good at showing us precise data. And we can even color code our tables to represent different things. So if we look at this table of train schedules in San Francisco, we can see when trains are going to depart. Maybe the different columns, the different colors represent different ticket prices. So we can represent different information using different colors and different. You can see all these different numbers. You can find the earliest train leaving San Francisco will leave at 4:55 a.m. Pie charts are a great example for showing percentages of a whole. If you remember back to our beginning of our class, I made this incredibly useful pie chart for you all. The real version of this pie chart is a little bit easier to read. My computer is once again freezing. I'll just look up there. We can see our pie chart here in actuality. We have our sections of our whole representing how many of each of these things we see in our class. So this is number of children if you're the middle child, the youngest child, oldest, or only child. So we can find the percentage of people in our classes who are the youngest in their family. It's going to be about 40% are the youngest in their family. Line charts are really good at displaying changes in a system over some amount of time. So if we look at this graph, this is a graph of, I believe, broadband internet connection or connectivity in European countries. So we can look at this graph, we can see from starting around 2002, 2003, going up through 2010, we can see these lines are constantly going up. We're improving their the connection to the internet, and we can see that Denmark and the Netherlands have the highest current connectivity, which is great. So if you want to explore any of these pieces of information, I have links to the sources down below. There are bar charts is another type of data visualization. These are useful when you want to compare different categories against one another. So here we have a graph of the most common items sold by different store locations. So we can see our different colored bars over here are the different types of items. And at the bottom, we can see our different locations. So in Austin, the best selling item is dark green, which refers to notepads. It looks like notepads are the best selling across all locations because they are the highest bar everywhere. We can see all of these informations throughout all of our different locations. A slight variation on bar charts are stacked bar charts, where instead of having all of our bars be side by side, we can have them on top of each other. So in this graph, we see the different film directors with the largest number of award wins. And the different colors are representing different genres of film. So we can see that Ethan and Joel Coen have won the largest number of total awards, but they only have 3 colors. They have done crime, they've done drama, and they've done thriller movies. Where if we look a couple to the right, if we look at Steven Spielberg, I can't say words, we can see way more colors in his column. So even though he hasn't gotten as many total awards, he's gotten awards in a broader variety of different genres. So he has a more varied skill set, for example. So this is just different types of information that we can glean from these graphs, and the lights are just off, I guess. Very, very similar to bar charts are histograms. They are very similar, but they are distinct. They are useful for showing the frequency of events. So let's say we have some sequence of results on an exam. We have the number of students in each category, and we have the grade ranges. So we have some number less than 10 who got between 0 and 10 points. We can see it going up and then back down. So most of the students in this class got between 50 and 60. It seems like it was probably a pretty tough exam. Now, one of the best ways to engage people in the information you're using is to make it interactive. I have links here to examples of interactive data. So let's look at this first one. This one is a map of the world. So we can hover over any of these points, and we can see the name of the city and how many people live in that city. So we can see a larger point is going to reference a larger number of inhabitants. So this very bright point, Karachi in Pakistan, has 11 million residents, where if I scroll to a smaller point, we have way, way fewer residents. We can actually even find our home city somewhere around here, San Jose. We have about 1 million residents. Unfortunately, can't zoom in. That'd be an improvement to this interactive data. But even just looking at this map, even without having to interact with it, we can see where different hubs of humanity are. You can see there's lots of people in India. There's lots of people over here in China. There's quite a few people over on the east coast of the US. There's quite a lot of people down here in Mexico and on the left coast of the US. So we can see these brighter hubs of light, seeing where there are lots of people. There's another interactive piece of data. Here we have from the EA Sports FIFA game, some of the top ranking players. So we can select different skills. So who is the best player overall? We can look at these different skills. Who's the best at crossing? Wait for it to load. And it'll shuffle and find the best 3 players at that specific skill. And we can do it for whichever skills we want within this soccer game. So the fun little interactive piece of data. And there are so many different interactive visualizations on this website. So Tableau is the name of a very popular data visualization piece of software. And within this piece of software, there is a public gallery that people have made for viewing these cool different pieces of interactive visualization. So if you want to explore some more, you can go ahead and hit that link and go visit that gallery. Now, often we're going to have to be creative in how we display our data. So if we look at this row of data, you can see a player, and it's LeBron James. Names. So we can see there's a whole bunch of numbers and a whole bunch of categories here. And by itself, I mean, it does show a lot of information, but it's hard to grasp what it means. Now, what we could do is if we visualize the data, if we plot these points on a basketball court on different places on the court, we can see a lot better what this information actually means. We can see his success in a variety of different locations. And if we're LeBron, we can see where we might need to practice, where we've been successful. And if we're an opponent, we can see where he is likely to shoot from, where he's been most successful. So we can use this data to our own advantage. So how are these visualizations used? Public data sets and data visualization tools allow widespread access to knowledge, which, like we talked about last unit, is always good. There are lots of different websites like Gapminder, Tableau, and the Google Public Data Explorer, which surface all kinds of interesting information that is publicly available. And each of those is a link to that actual website. Now, these tools enable anyone who wants to try and draw conclusions about the world to do so. They can look through this information, they can try and visualize some subset of it to try and gain knowledge about the world around them. So there is our discussion on data visualization, making our information visible and readable. And there you have it. Any questions on any of that? Cool. All right, then I will stop our recording.